This is our lesson on the cosine law, and just you probably have noticed it's 8.2 and 8.3. So in the textbook they have divided it up into two lessons. One is just solving for side lengths and one is solving for angles. So we are going to be putting those together into one lesson here. So that's why when you do the homework, you're going to see that you have questions on two different pages, and that's just because the textbook has split this up. So looking at these two triangles here, can we use primary trig ratios or the sine law to solve either of these triangles? Explain. So when we first look at these, I can automatically see that there's no right angles. So that means we cannot use trig ratios. And if we wanted to use the sine law, we would need that side angle pair. So we would need an opposite pair. And looking at the first triangle, there are no angles. So there's definitely not any pairs in that one. And then in the second triangle, we do have an angle, but there is no side length across from it. So there's no opposite pair there. So primary trig ratios, that's SOHCAHTOA. When we say primary trig ratios, we're talking about SOHCAHTOA. Those are only used to solve right triangles. We cannot use SOHCAHTOA if there is no right angle. So they can only be used in right triangles, which of course neither of the above are. The sine law can only be used to solve triangles if you know either two sides and an angle opposite to one of the sides, or we're given two angles and any side. Okay, and both of these statements actually relate to that side angle pair. So in the first one, if you have two sides and an angle opposite to one of the sides, then you have a side angle pair. So if you have a side with the angle opposite, you got your side angle pair, your opposite pair. The second example, if you have two angles in any side, you can actually find the third angle by just taking 180 subtracting the other two. So really you have all three angles and a side, which means you again have an opposite pair. So both of these statements relate to having that opposite pair. That's what we need for sine law. So there are cases like the above two where this does not happen. We do not have a side angle pair. So in this case, and in only this case, you are going to be using something called the cosine law. So just like when we were factoring, factoring by decomposition was always our last resort, just because it's the most difficult. Cosine law is our last resort. If we've tried everything else and it doesn't work, we can't find anything, we're going to use the cosine law. And I'm going to write this out for you. You wouldn't have to memorize this. You're not having an exam this year anyways, but you're always going to be given you the formula here. So a squared equals b squared plus c squared minus 2bc cos A. So you would use this particular formula if you're finding a side. And that's because it starts off with the side length all by itself on the left side of the equal sign. So that's the little a, which is a side length. Also, we can just kind of rearrange this for b and c. So if we wanted to solve for b instead, and there's actually a pattern here. So it's a squared equals b squared plus c squared, which are the other two sides. Same thing for this one. So b squared would equal the other two sides squared. So the other two sides are a and c. Minus, we're going to look at above again, we got a 2. We have b and c, so that we have the two other sides. So if I'm starting with b, my two other sides are ac. And then cos, again, we have capital A over here, little a over here. So if we have little b, we're going to have capital B. So as long as you have one of the formulas, you can figure out the other ones just by following the pattern there. So we got the square of the other two sides minus 2 times the other two sides, cos of the angle opposite the side we're trying to find. So in this case, we'd have cos C. So there's your formula for cos law finding a side. We can also rearrange this stuff. So if I wanted to rearrange this top formula, I'm going to rearrange so that I have cos A all by itself, because anytime we're finding an angle, we would want that all by itself. You can rearrange this stuff. So we're going to take A squared. We're going to move the B squared and C squared over. So we're going to have to subtract those. So because it's plus on the right, when you move it to the left, it's going to be minus. And I just wrote a plus. Minus over, and because I have this negative 2bc cos A, if I want to get cos A all by itself, I'm going to divide by negative 2bc. So I would divide this by negative 2bc. That's going to give me cos A. And I want to simplify this as much as possible. So I see a lot of negatives here. I'm actually going to take a negative out. And when you take a negative out, you're left with A squared plus B squared plus C squared. Equals cos A. And then my last step, if I rearrange what's in here, oh, that should be a negative there. Like, what did I do wrong here? That should be a negative out front. So now if I rearrange this so that it's B squared plus C squared, take my minus A squared, put it at the end, and then these two negatives are going to cancel out. So you're left with 2bc. So if we had to do that every time we were solving for an angle, that would be not nice. So we're just going to write these formulas down so that you can use them. So if you're finding an angle, these are the formulas you're going to want to use. So cos A equals B squared plus C squared minus A squared all over 2bc. Just make sure that was right. Yeah, good. Okay, so if we're going to solve for cos B, if you're trying to solve for angle B, again, it's a pattern here, right? So this is the other two sides squared, so A squared plus C squared, minus the opposite one you're trying to find, so minus B squared, all over 2, and it's the other two sides. So the other two sides are AC. And then the last one, that's the other two sides squared, minus the side opposite squared, all over 2 times the other two sides. So I'm just kind of showing you the pattern here because sometimes they give you triangles that's like X, Y, Z or something like that, and you're going to have to try to figure out the formula. Now, if you can't do that, if you really can't see the pattern and you don't want to work with X, Y, Z, you could always relabel triangles as A, B, C. So the cosine law can be used to solve triangles when the given information includes, so you're either given two sides and the contained angle. That just means the angle in between the two sides. Angle. Or you're given all three sides. All right, let's do some examples here. So I see how I have X, Y, Z instead of A, B, C. So again, if you do not want to try to manipulate these formulas, you can change those to A, B, C. As long as you have little a across from big A and little b across from big B and little c across from big C, you can just change the labels. However, I'm going to work with the X, Y, and Z that we have here. So I want to solve for little y. I can see that some of this stuff isn't labeled. So across from big Z is little z, across from big X is little x. So I'm trying to find little y, which means the first thing that I'm going to write down is what I'm trying to find. Trying to find. So when I look back at the formula on the other side of your sheet or above, if you've written above, it's y squared equals the square of the other two sides. So I have x and z, so x squared plus z squared. minus 2 times the other two sides, so xz, cos of the angle opposite the side we're trying to find. So if we're trying to find little y, we're going to use cos of capital Y here. That is a bad capital Y. Okay, so we're going to fill in everything we know. X is 11, so 11 squared. Z is 8. Again, X is 11. Z is 8. And capital Y is 36 degrees, so cos 36. Okay, so when I plug this into my calculator, I actually always plug this stuff in and then this stuff in two separate steps. So I do 11 squared plus 8 squared, it gives you 185. And then I take negative 2 times 11 times 8 times cos 36, and that gives me negative 142.38699. Now you want to keep a lot of decimals here, so keep decimals for accuracy. Okay, so if you round to like 142 or 142.4, your final answer could be a lot off. Not a little off, it could be a lot off. So just try to keep as many decimals as you can until the end. So if I subtract those, I'm actually going to get 42.61301, and that's y squared. So a lot of times your error at the end is you just forget to take the square root. So make sure you take the square root of this, which is going to give us 6.5 inches. So here's where you can round at the very end. And it was the nearest tenth it told me in the question, so 1 decimal place. Okay, so that's how you use cosine law trying to find a side length. Now we're going to use it trying to find an angle. So again, they've labeled the angles here, but they didn't label the sides. So I'm just going to go ahead across from big C's little c, across from big A's little a, across from big B's little b. And I can't use sine law because I don't have that side angle pair or an opposite pair, so I'm going to be using cosine law. And I'm trying to find angle C. So I'm going to use the formula that has the big C at the beginning. So that's cos C equals a squared plus b squared minus c squared all over 2ab. All right, going to sub in what I know. Little a is 16. Little b is 17. Little c is 14. All over 2, 16, 17. Again, I do this in 2 steps. I'm going to calculate the top, 16 squared plus 17 squared minus 14 squared is 349. And then I would go ahead and calculate the bottom, which is 544. And then always, 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 when you're finding an angle, use that inverse. So C is actually going to be the cos inverse of 349 over 544. Okay, so make sure you know how to plug this into your calculator. We are going to get 50 degrees. And again, that's rounded because it wants us to round to the nearest degree. So we're basically just subbing things in formulas and solving. And then we have a question that says to solve the triangle given the following. Again, I usually set up a nice little box here just so that I can make sure I find everything we have. It's ABC, so angle A, angle B, angle C, and then we have little a, little b, little c. So I'm given A is 9, B is 7, C is 8, and I'm just going to draw a triangle. Remember, it does not have to be to scale. We got A, B, and C. Doesn't matter which ones you label where, as long as your little a is across from your big A, your little b is across from your big B, and your little c is across from your little c. So we are given that B is 7 centimeters. My A is 9, and C is 8. Again, you can see it's not to scale, but that's okay. So we're going to start off, we need to find one of our angles. So we're just going to start off and we'll find, let's say, big A. So it doesn't matter where you start. I'm just going to start with big A. Because I don't have a side angle pair, I'm going to have to use Cosine Law. And because I'm finding capital A, I'm going to use the formula that starts with the big A. So cos A equals b squared plus c squared minus a squared all over 2bc. If I sub in what I know, we're going to get 7 squared plus 8 squared minus 9 squared over 2bc. 2 times 7 times 8. And again, I always like to calculate the top, so I would just go ahead and do 7 squared plus 8 squared minus 9 squared, which gives me 32. And 2 times 7 times 8 gives me 112. And then again, I'm finding an angle, so I am going to be using that cos inverse. You should practice that in your calculator. Maybe pause the video if you want to try that. You are going to get 73 degrees. So my A is 73 degrees. Okay, let's go ahead and find B. So since I have an angle now, when I look at my triangle, I actually do have that side angle pair. So instead of using cos law again, which you could if you love cos law, go ahead. But sine law is a bit easier. So because I already have the side angle pair, I'm actually going to go ahead and use sine law. Since I'm trying to find capital B, I'm going to use the sine B first. That's the first thing I write down. And then I'm going to use my opposite pair, which is the A. So there's my sine law. When I start subbing things in, I'm going to know everything but capital B. So I got sine B over 7 equals sine 73 over 9. I'm going to want capital B all by itself. So I'm going to take that 7 and multiply it on the other side first. And then because I'm still solving for an angle, I'm going to have to use that inverse. So again, this is good practice with your calculator. You can try pausing the video, try plugging that into your calculator, and you will get 48 degrees. I'm just going to try that in my calculator here. 7 times sine 73 divided by 9, 74 degrees. Whoop. Sine inverse. 7 times sine 73. Yeah, 48 degrees. Sorry, 48 degrees. I was right. So 48. And now that you have two angles, your third one should be super easy because we know that all three angles add up to 180. So let's just take 180, subtract the 2 we have. We're going to get 58 degrees. So because I have my little square up here, I can tell that I have officially solved it because we have all the angles and all the sides. So lots of practice for you guys to do here. This again is listed in your binder as well as in the announcement section of your D2L homepage. And if you have any questions, which you're probably going to have some questions, don't forget to email me and we will take this up in our next meeting.